team of astronomers used ALMA to look at the seventh planet from the Sun, Uranus. The observations were made to look at the atmosphere of the giant planet, but the astronomers got a surprise. They could see one of Uranus's rings. Yep, Uranus has rings similar to Saturn's, made up of countless particles of water ice, but much darker, thinner, and fainter. They were only discovered in 1977, and up until now only seen by feebly reflecting sunlight. But ALMA sees them glowing due to their own heat, if that's the right word to use, because it found them to be at a temperature of a very chilly -320 degrees Fahrenheit. Still, that's a little bit of a higher temperature than expected. Something is keeping the ice particles in the ring warmer, but it's not clear what. The observations also indicate that those ring particles are bigger than expected, at least 1 centimeter in size. That's a pretty cool observation, especially one taken from nearly 2 billion miles away. And it was a surprise to see the ring at all, too. Scientists love unexpected things, since they're a chance to learn more about the universe, even a part of the universe that's in our own neighborhood. "1,500 light-years from Earth, a young star, prosaically called Orion Source 1, is still forming. It's surrounded by a massive disk of gas and dust, its birth cocoon. This is fairly common. Stars are born from such disks. But what makes Orion Source 1 special is that astronomers have detected a ring of sodium chloride, table salt, around it. The observations were made using ALMA, which is sensitive to the kind of long-wavelength light emitted by sodium chloride. The detection surprised astronomers, since this has never been seen before from a young star. Sodium and chlorine are common around dying stars at the ends of their lives, but seeing them together as table salt around a young star is unprecedented. It's not clear where the salt came from. One idea is that dust grains in the disk with salt molecules in them collided, freeing the salt and allowing it to be detected on its own. The amount is staggering. 1,000,000,000,000,000 tons of salt orbit the young star. Despite the huge quantity of it, that salt would have remained invisible if it weren't for ALMA. What other surprises wait for us when we point ALMA at other young stars in the sky? ALMA has fangs. If you spell it with a PH, that is, and let it mean physics at high angular resolution in nearby galaxies. That's a mouthful, but what it means is that ALMA is taking a very close look at nearby galaxies to get as much detail from them as possible. And not just any galaxies, but spiral galaxies. Those magnificent spiral arms are where stars are born inside huge gas clouds called nebulae, and we see them due to the glow of gas warmed by those newborn stars. Astronomers surveyed 74 nearby galaxies with ALMA to look at their carbon monoxide gas, which is abundant in stellar nurseries. They want to map the locations, brightness, small-scale features, and velocities of these gas clouds, tying them to larger features in those galaxies, like the arms themselves. A big survey like this is perfect to compare and contrast different galaxies, helping astronomers understand just how and where stars are born. They've observed over 100,000 nebulae so far, and expect to see 300,000 before this survey is done. That's a lot of stars and a lot of science, thanks to ALMA. NGC 3258 is a galaxy about 100 million light-years away. Like every other big galaxy, at its heart is a supermassive black hole. But how supermassive? How big is it? Well, like many monster black holes, there's a disk of gas and dust orbiting it. This disk is huge, well over 1,000 light-years across, very cold in its outer parts, and has lots of molecules of carbon monoxide there. This is where ALMA comes in. It can probe the gas in this disk around that black hole with unprecedented clarity, better than any telescope on or above Earth. And it can also determine the velocity of that gas. By using the Doppler shift in the signal, it can accurately measure how rapidly that gas is orbiting the black hole, even as close as 65 light-years from it, where the gas is screaming around at over 2 million miles per hour. The speed that material orbits depends on the mass of the black hole, and the ALMA observations indicate this one is truly a beast. It has 2.25 billion times the mass of the Sun. This may be the most accurate mass measurement of a black hole ever made. And ALMA's not done yet. There are always more galaxies out there it can observe, more black holes to measure. Every big galaxy in the universe has a supermassive black hole in its center, with millions or billions of times the mass of the Sun. If gas falls toward that black hole, it'll pile up in a huge disk circling it, stretching for dozens of light years. The galaxy NGC 1068 is 47 million light years away from us, and is known to have such a huge disk swirling around its central monster black hole. New ALMA observations, though, shocked astronomers. They show it actually has two disks, one closer to and one farther out from the black hole, and they orbit the black hole in opposite directions. The inner disk is 2 to 4 light years from the black hole and spins the same way as the stars in the galaxy. Call it counterclockwise. The outer disk is 4 to 22 light years out and spins the other way. The most likely explanation is that NGC 1068 suffered a collision with another galaxy, and the gas from that interloper fell toward the black hole, creating the outer disk moving in the opposite sense as the pre-existing inner disk. Eventually, it's expected that gas will drop down to the inner disk and will begin to spin along with the rest of the galaxy. That'll create quite the show in a few million more years. You might recognize this object as Jupiter, the biggest planet in our solar system. If it looks a little odd, that's because this isn't a visible light image, but one taken at the much longer wavelengths ALMA sees. The image shows the stripes of Jupiter, called belts and zones. In visible light, zones are bright and belts dark, but to ALMA's eye, that's reversed. Zones are at a lower temperature than belts, and at these wavelengths, ALMA senses the temperature of the gas, so the cold zones are darker and warm belts lighter. ALMA observed Jupiter just a few days after some large storms erupted from deep within the atmosphere. ALMA can detect gas down to 50 kilometers below the cloud tops, allowing scientists to make a 3D map of the way the gas moves inside Jupiter's atmosphere. They could see how air laden with ammonia and water vapor rises, cools, and flattens out when it reaches the tropopause, the coldest layer of Jupiter's atmosphere, much like massive storm clouds do on Earth. Jupiter's atmosphere is in many ways alien and complex, but ALMA is showing planetary scientists that there are some similarities to Earth, and that helps us better understand both worlds. There's a disk of gas and dust spinning around the newborn star HD 163296, and the star isn't alone there. 3 planets orbiting the star have been detected by ALMA, their gravity sculpting gaps and swirls in the disk material. The disk is loaded with carbon monoxide gas, which glows brightly at the long wavelengths ALMA detects, allowing astronomers to map this gas with unprecedented clarity. Using this data, they can analyze the 3-dimensional structure and velocity of the gas. What they found was startling. Gas flows along the top and bottom sides of the disk toward the gaps carved out by the planets, then falls down the edges of each gap toward the still-forming planet, like a river flowing over a cliff. It's a gas waterfall. This type of flow has been theorized since the 1990s, but never seen before now. Because of these ALMA observations, we're witnessing the creation of planetary atmospheres. Discoveries like this help us understand how the planets in our own solar system formed, including Earth. Sometimes we have to look up into the sky to understand what once happened beneath our feet. ALMA, along with 6 other telescopes around the world, combined their abilities to create the Event Horizon Telescope. They observed the very center of the elliptical galaxy M87, which is 55 million light-years away and hosts an enormous black hole with 6.5 billion times the mass of the Sun. That ring of light is superheated material circling the black hole. The black hole itself in the center is invisible. Not even light can get out, so we can't see it directly. The dark region just inside the ring is where photons, particles of light, orbit the black hole before falling in, so we can't see them. In a sense, we're seeing the shadow of the black hole. ALMA was critical to this image. Without it, that central hole wouldn't have been seen. And this is just the beginning. Astronomers will turn next to Sagittarius A star, the supermassive black hole in the center of our Milky Way galaxy. Those observations are coming soon, so stay tuned for more exciting results from the Event Horizon Telescope and, of course, from ALMA. Stars and planets form from huge clouds of gas and dust that collapse down into disks. The star forms in the center of the disk, while planets form farther out from colder material. Up until now, we've only had a glimpse of this process, but with ALMA, that turns into a wide-eyed stare. That's thanks to D-SHARP, the disk substructures at High Angular Resolution project, where ALMA took extremely sharp observations of 20 young stars and planetary systems, teasing out details never seen before. Gaps in the disks carved out by growing planets can be seen in many systems, while others have bright spots which may be forming icy bodies like comets. One observation even shows a nascent binary star system forming. One star, AS209, has a Jupiter-sized planet that appears to be only 1 million years old. That's extraordinary for a planet. Up until this observation, it was thought planets like that took tens of millions of years to form. ALMA is rewriting what we thought we knew about how planets are born, including ones like Earth. Given that we live on Earth, these observations are important not just to astronomers, but also to any scientist, any person curious as to how we got here. Roughly half of all stars in the sky are in binary systems, 2 stars orbiting each other. Now, we know all stars are born from clouds of gas and dust that collapse into disks, and the star forms in the center. But what if there are 2 stars there? How does that work? We know that there's a disk surrounding both stars, far out from them, but we've never seen what happens close into the stars until now. For the first time, ALMA observations have revealed the strange way binary stars grow. BHB 2007-11 is a young binary system 530 light-years away. Detailed ALMA observations show that each star has its own disk a few hundred million miles wide, with both embedded in that much larger disk. Material falls in from the big disk to the smaller ones, but gets stirred up by the orbital motions of the stars. It forms twin spiraling streams, looking like a pretzel, circling around and eventually falling into the stars via their smaller individual disks. Those filaments are over 35 billion miles long. This ALMA observation is already confirming some ideas astronomers have of how binaries form. As bizarre as this system looks, it may be the most common way stars in the sky are born.